Testing. Oh, okay, now it's working. I'm so sorry. Like when we switch from the grading to the Twitch, I use a different headset. And sometimes for reasons unknown, this headset, like it makes the sound of connecting. It makes a little sound. I can hear that it connected, but my computer decides to stay on the previous headset. Like it thinks it's still active. So then you guys can actually hear me, but you should be able to hear me now. So what I was saying is that it's really important that you do the little question things, this three, this three, this three. These are the mini questions. It's 7 times 3. It's 21 points from the mini questions. You have to do at least some of those. The exam's going to be 20 and 20. So just doing the exams, you're not going to pass the class because that's only 40 points. And even if you make a perfect project, you're still at 55. You have to do some homework. You cannot pass the class with no homework whatsoever. So in the pending results, you can look at the results now. The E1s are the first 3 mini questions plus the thing we graded last week. E2, it's going to be the 3 mini questions from chapter 2 plus what we just graded today. E3 is going to be the 3 mini questions we're going to be looking at today, plus the thing we grade next week, and so forth. But you guys have to start doing this stuff. There's no excuse for not having a 3, 3, 3, 3, 3, 3. If you have more than 3, you're working wonderfully. If you don't even have the 3 plus 3, there's something horribly wrong in how you're taking this class. When you haven't done the mini questions for chapter 2, it's very unlikely you will understand very well what's going on in chapter 3, because the ability to answer those questions means that you are in condition to actually start looking at what we're going to be doing for chapter 3. So here, these 3, you should have them done. They're really easy. Just put the code, substitute the values, print it out. 3 points. In this one, you actually have to think, what are you going to put in here? Try something. If it doesn't work, put a screenshot on Discord and we'll talk about it. One little expression here, one little expression here, one little expression here. And then today, we're going to have these other 3. And as you notice, these are again printouts. So these are again 3 points. Just put the values and run it, it's going to print out. Then try to figure out by hand, why does it print out what it's printing out? But to get the 3 points, you don't have to understand anything. So this is the part I'm struggling with. Why don't you guys have these points? Because this is ridiculously easy. I'll show it to you again. Look, you go to online GDB, you select C language, you go here, you copy the question, you select everything in online GDB here to put that thing. Then you look, it says A is 50. You go here, you type 50. B is 12. Look, B is 12. I type here 12. Okay, now I run the code. Look, it printed 39. I will type here 39 and I will grade and I will have a point. Why are you guys not doing this? Can everybody please do at least one of the exercises, either in exercise 1 or exercise 3 right now? Go to the exercise system. When you load the page, it asks for your email. You will put the email you registered for the homework. If you haven't registered anything, just put the email you want to register. Go to either exercise 1 or exercise 3. Copy paste one of the codes that you haven't answered correctly yet. Substitute the values. Where it says X, you put that number. Where it says Y, you put that number. Run it in online GDB. Copy what it printed out. Put it in the box. Go underneath the exercise and click grade. I'm going to grade the 39 that I just got here. 39. It just printed me a 39. So even if I haven't looked at the other 2 questions, I scroll down and I click the grade and I should have the answer. Why am I not getting the right answer? Oh, because it's a different value now, because these are my values now. Previously, I hadn't done a login. And when I don't do a login, I'm not looking at my own numbers. I'm looking at an example. So the correct answer is 76 with my A and my B. Let's grade it with the 76. And now I have a free point. Everybody, please do this. If you're listening to me now, please go do at least one of these exercises, because it's really breaking my brain that these are free points that you guys should be getting and you're not doing it. It takes 15 seconds of your time. I am giving away points here. I'm going to link the system. So you're supposed to be in the homework system here. And on the result list, I'm also going to link it again. In the result list, if you haven't registered your email before, you will on this site put the email here. You will put your student ID, you will pick your study program, and you will click register. Then the points you've gotten will appear here. This person, this person, this person, this person, this person. What is going on? Why do you not have these points? I really, really, really need you guys to have these points. Really. If you have no idea how to copy paste code into online GDB, if you don't know where online GDB is, just ask me. You can ask in Spanish. This is really easy. If you don't understand the exercise because it's in English, you will go to Google Translate. You will take the exercises that you do not understand, you will copy them, you will go to Google Translate, you will make it translate them into Spanish. And it's usually pretty much understandable. If you don't understand it, you will ask on Discord. But there is no reason not to do this, none whatsoever. So also these people, I'm really confused here. They did the first ones, but they did none of the second ones. You need to be asking questions if you can't do those. But yeah, everybody should be able to do the E3 ones because they're just printouts again. Okay, so today we are looking at chapter 3. Let's go look at what chapter 3 actually contains. Control flow. So we are talking about if else, else if, switch, loops again. We're going to look at the fact that goto and labels exist, and we're going to agree on never using them. Break and continue are very important things. I was actually using a break. Actually, I was using a return. Using a return in place of a break, but you could use a break if we don't want to use a return. Those are very handy things. So we're going to be looking briefly at the if-else structure. Again, we talked about it in chapter 1. We're going to revisit it so it becomes really clear. We're going to learn a new option. That's a switch case. We're going to look at the loops we already know that are while and for. We're going to learn a new loop, that's the do while. And then we're going to make sure we understand how to use break and continue for all the loops that we have. As before, you supposedly have read chapter 3 beforehand. We're supposed to be discussing things that you already read. If you're not reading the chapters, you will be slightly confused, but that's on you because you chose not to read the chapter. So, the if-else expression is essentially thus. We say that if some expression evaluates to true, then we do a first statement. If it doesn't, we do a second statement. As we talked about in the first chapter, the else is optional. We could just say, if this is true, do this. If it's not true, do nothing. We can also optionally add all the else ifs that we want. We could put ifs inside other ifs. We could put an if without an else inside an if. And when we start doing weird stuff like this, putting stuff inside one another, it's important we use the curly braces to group which things actually belong inside which other things. Like here in this example, there's an if that contains a for that contains an if. This is a bad idea to skip the curly braces on the if and the for because it will be difficult to read and your reader will struggle to understand where this else belongs, whether this else belongs to this if here or whether it belongs to this if here. So now, since there aren't any parentheses here, we are going to try to put this else with the inner if, even when the person wants it with the outer one. So if I wanted to go with the outer one, I need to put a curly brace before the for and then a curly brace before the else. Let's practice this a tiny bit using a structure much like what's in the book so that we can see what's going on here. So let's go to the repository. To the chapter 3 ones. And make a new example. Let's make it print something so we can see what it's actually doing. I'm hoping the volume is okay now. Nobody has complained anymore. Okay. So now you can see that my editor, it wants to put the else at this level. If I try to put the else here in the beginning and I press tabulator, it pushes it inward. But let's write it like it's written in the book. It moves it. My editor doesn't want me to make mistakes. Okay, so now this is a poorly grouped code and we can run it. Let me open it in another window. So we can compile it here. I'm going to compile if else. Come on. Okay, and look, I get a warning. It's saying that I'm doing something dangerous. There's an else that is unclear where it goes. So now if I run this program, I get the 3 olas, because now this ola, this else ola, was an else for this if here, so it went inside the for. If I don't want it to be inside the for, I need to add a curly brace here, and then I would put a curly brace in front of the else, and to make it look a little bit better, I would put a curly brace here too. Compiler's not going to cry about it anymore, because it's not a dangerous else anymore. It's now clarified where it belongs. And now it doesn't print any olas anymore because it actually went inside the if. The same way, it would be a wiser thing to add another set of curly braces for the for, even though we don't actually need them. The whole point is here to every single block I have, that this if goes from here to here. This for goes from here to here. This if goes from here to here. So every set of curly braces is a block. And we need to put the curly braces so that we can easily understand what's going on. Omitting them can create dangerous situations because if you don't put them, and let's say you just have this print here, it all looks wonderful now, it all works wonderfully now. Then if you later want to add the return, unless your editor is like mine and it insists that the return doesn't belong inside the if, you might think that the return is now inside the if, but it's not. Now the return is outside the if. So we are going to do the return regardless of whether we actually printed low. So now we printed low and we also did the return. If I, no, actually we didn't do this return, we did another return. Which one did we do? 14 is larger than 5, we did this one. Yeah, we did this return. We first did the if and then we did the return. Now, if I only wanted to do the return in the case that I didn't do the if. Let's put it a smaller number again so it doesn't do it. So now it didn't do the lol, and it did the return. So let's say I don't want to do the return, but I do want to do this part here. I could put the return inside a block. So I only do the return if I printed lol. So now in this case, it actually goes all the way to print by, because now the return is inside this if, not outside this if. So just putting too many curly braces, it can't hurt you. Not putting curly braces can get you lost in which things belong in which blocks. So it's a bad idea. The second thing we learned from chapter 3 is that we can make multiple else if. So that means that we can make structures like, if this is true, we do this. If this other thing is true, we do this other thing. If this other thing is true, we do this other thing. So I can make as many as I want. So let's make some else ifs here on inside. Find my other terminal, compile, run. So now this else if way, it will be done if 12 is larger than 3, but 4 wasn't larger than 5. If we do the first one, we're never going to do the second one, because it's, if this is true, do this. In the other case, if this is true. So if both of them are true, we're just going to do the first one. We're not going to do the second one. That's the structure of an else if. So let's push this thing into the repository. You guys can look at it from there. And let's look at our new friend switch case. If I need to do a lot of options, that if this, then this, if this other thing, then this other thing, I don't usually want to make a huge bunch of else ifs. If the options I'm choosing from can be mapped to integers, I am going to use a switch case. I can put as many cases as I want, and then I can make a default case, which is the one we make if none of the other cases were met. So let me copy here the contents of the if-else file. So let's make here a switch case. Let me take a character C, and I'm going to get it with a catch-r. Then I can make a switch with the C, because characters can be mapped to integers. So then I can make these cases. So in each case, I can define what do I want to do if the value was equal to this constant expression. So here I could put a printf, it was an A. And here I could put an it was a Q. And then in the default, I could put it was something else. Now, this program is purposefully wrong. It's not going to do what I just said it would do, but I'm going to show you what it does so you guys learn to recognize this mistake. So I'm going to compile my switch case file, and I'm going to run it. It's waiting for a letter. I'm going to press an H. Okay, so now I got it was something else, and everything looks kind of fine. I just have an extra dot here at the end. Let's take it away, compile again. So everything looks fine when I put something that isn't an A or a Q. But let's run it again, and I'm going to give it an uppercase A. Now it says it was an A, it was a Q, it was something else. My problem is that it's going to flow through the cases. If it's A, it's going to do everything under A. If I give it a Q, it's going to do everything under Q. So if I want it to do only this case, I need to put a break, meaning that I want to do this stuff here until the break. So for the intended behavior of picking only one of the branches, I need to add those breaks. Now if I compile and I run it again, and if I give it an uppercase A, it says it was an A and it doesn't do anything else. If I wanted it to do something at the end of everything, I would put it outside the switch case. Because the default will only be done when none of those cases were met. I'm giving it a Q. It was a Q. By now, my E didn't work. Okay, so that's a switch case. You can make it pick between options. The only rule is that these things have to be essentially integers. But remember, letters are essentially integers because we are representing them with the ASCII code like we talked about last week. So switch case is very, very, very nice. There's a very good example program here that's counting digits, white space, and whatnot. I would recommend writing this into your editor, compiling it, and working with it for a while. Know that they're grouping cases together. So they're treating zeros all the way to nines with the same thing. Then they're grouping another group where the white spaces, the enters, and the tabulators, they make another group. So this is a very good example to better master how a switch case is working. Okay, let's send this one into the repository as well. And then let's work with the loops. So we already know a for loop, and I already told you that the for can be written as a while because the for has those three blocks. What do I do before I start? What's the condition I evaluate, and what do I do after? So the first one would go outside the while. The condition would be the condition of the while. Whatever happens here inside would happen in the while first, and whatever happens here would happen inside the while last. So we already know both of these, and as I was doing in the example for the discussion of chapter 2, you can skip some of these parts. So let's throw the switch case file here so I don't have to type as much. And make some examples. Let's make an int I. So I could make an for I goes, let's say, from 3 while it's less than 10. I could make it increments in steps of 2. And then I could just print out the values of I. Just to see how this stuff works. So now I have a little for that iterates regularly in increments of 2, starting from 3, ending when it reaches 10. So what's it going to do? I'm going to get the 3 and the 5 and the 7 and the 9. That's a for loop. Then I could make a while loop. Let's say while I is larger or equal to 0. I could do something to while, to I. Let's say I could divide it by 2 and then print it. So now the problem is I'm dividing by 2. It eventually reaches 0. And 0 divided by 0 is a 0. So I have an infinite loop. So let's make it that the equality doesn't count. It has to be larger. And now I don't get an infinite loop anymore. Now, what does the do while do? The do while is a very interesting thing because it says, do whatever's in here at least once. After you've done it, evaluate the while. If the while is true, do it again. So whereas in the while, if the condition isn't true, we never do any of the stuff inside. In the do while, we do the stuff even if the condition isn't fulfilled. So I could do this here, like while I is larger than 0, I would have to print hello and then decrement I by 1. Now we know that I is already 0 when we come out of the while because it's the last thing we printed. So this stuff here will happen even though I is not larger than 0. It's going to happen. This one doesn't have to be inside the print because we're actually not printing it. Actually, we could print it. There, let's print it. So notice it did it one time, even when I wasn't larger than 0. If I were larger than 0, let's add it a 3 here. It'll do it for the 3, do it for the 2, do it for the 1. But then when the 1 has reduced here to a 0, I is no longer larger than 0, so we don't repeat again. So the do while is an at least once kind of a loop. And it's very nice to have a loop where you can do stuff at least once. And then you keep repeating until the condition is no longer valid. So we have 3 different kinds of loops. Let's send it to the repository as well. I recommend reading all of this, looking at the examples that are using different kinds of loops. Here we're using a for loop with no curly braces because it's a very simple block. Here is a for that doesn't have anything inside. Here I have one for inside another, and then there's a third one. All of them have all of the 3 sections defined. I would personally put curly braces also on the first 2 fors to make it a little clearer. Another for in here, the special thing about this part is notice it has 2 initial conditions. It does 2 things before it starts. They're separated by a comma. And it also has 2 post operations. It does 2 different things at the end of each repetition, also separated by a comma. The exercises are very good. There's an explanation of the do while here. And now what remains to be checked today, very importantly, are the breaks and the continues. What do breaks and continues do? Let's copy the loop file. And let's make an out.c because what we're going to be doing is breaking out of loops. Let's add here a condition. If I happens to be divisible by 7, we are going to break out of the loop. So it means that we're going to iterate here 3, 5, then it's going to notice, oh, fuck, 7. And it's going to break. It's never going to try the 9 anymore because break breaks literally the loop. So we're not going to repeat anymore when we reach a break. Another option we could do, let's look at here what it was printing the 3, 5, 7, 9. So now it's not going to print the 9 anymore. If we look at what it does, let's compile that, print it, the 9 is now missing. So now let's look at what we can do with this, with the continue statement. So what does a continue statement do? Let me increment I here so it goes a little bit higher. Let's multiply I by 5, run this program. So now we go 17, 8, 4, 2, 1, 0 during the while. So now let's make it so that any odd numbers, we don't print them. We only print the even numbers. So I don't want to stop when I hit an odd number. I would like to continue. So I don't want to print this 17, but I want to continue down to the 8421. How would I make it so that I don't print the 17? Well, I could make it so that before the print, I would check that if I modulo 2 is 0, so it's an even one, I print it, okay? This is one way of doing it, that I only print the even ones. We already know this way. Let's look at it. But I have another way of doing this. I could make it so that if I have an odd number, then I continue. Meaning that if the number is odd, I don't want to do any of the remaining stuff here anymore. And I get the same exact behavior. So this simply means jump to the next round. So anything after a continue, it will not be executed for this value of I. But the next round will begin afresh and might do the whole thing. So break brings you out of the loop, and while makes you ignore the rest of that step. That's the primordial difference between the two. And what if I want to break out from two different loops? Oh, I broke my whole code. Let's make an inner loop here. Let's make a for. Let's take another J. J here. Let's make it that J is gonna be 2 times I, and while J is larger than 1, let's just decrement it by 1. So I could add here another thing inside. To show the values of J. Compile, execute. So now I get these at J, at J, at J, at J. Now let's say when J hits 3, I don't want to do this anymore. I don't want to do the for, and I don't want to do the do while either. I want to break out of the whole thing when J is 3. So let's say if I put here when J is equal to 3, I would like to break out. This is a marvelous attempt, but it doesn't do what I want because it only breaks the inner for. It doesn't break the do while. I need a second break for the do while. So how do I tell the do while that I want out? I could have another variable like a flag. I could put the flag here that first everything is okay, the flag is 1. But when I need to leave, I would put the flag to 0, or vice versa. I could put it that the flag is lifted when I want out and the flag is turned off in the beginning. Then in the other thing, in the do while, I need to check this flag. I will need to check here that if the flag has been raised, I am also going to break out of the do while. So now when J reaches 3, I don't only break out of the inner for, I also lift the flag and I use the raised flag to indicate that I also need to print out of the breakout of the do while. Another thing I could do, since the only thing I have remaining here is I could just return from up here. But if there's something interesting that I still wanted to do in the program after the while, then I cannot just use the return because the return will interrupt the entire execution of the program. And if I wanted to always print the by, then I can't return here, but I have to use a flag to break out of the outer loop. So break only breaks the immediate loop it's inside. If you need to break out further, you're going to use flags. The remaining section here talks about go-to and labels. Okay, and they're saying that it's infinitely abusable. I will not let you in this class use it at all because of that fact. You can abuse it as much as you want. It's kind of like making wormholes. You can tell the program that if something happens, jump to this other place. Let me send this thing to the repository. So basically you could say if bad things happen in here, then we are going to jump out of all that into the label error. And the first time you see this, you're like, this is wonderful. I don't have to do any of that bullshit with the flags. I can just jump wherever I go. The problem is you can always write your code better without using the goto. And when you start using go-tos, you usually make a huge mess of your code that you don't understand and other people don't understand either. And that's what they're saying here. Using go-to makes your code much more difficult to understand, more difficult to alter, and they shouldn't really be used. In very few cases, there's an explanation on why you need to use a go-to statement. And an introductory programming course like this one, there is absolutely no excuse ever to need a go-to statement. If you're using a go-to statement, you are not thinking enough and you need to think harder. I will not accept any codes with go-to statements. It's good to know they exist, but it's not something that's good to use. It's very important to remember you guys need to read chapter 4 before next class. We're going to start working better with the subroutine stuff, which is what we were doing in the example of the homework today. I had one routine that checked for prime and another routine that got the bits. That's going to be mandatory in the program that you make as homework for chapter 4, because we're all also going to know how to use functions at that point. So this homework 3, if you want to use them, fine. You don't have to use them. Next homework, you actually, literally, will have to use them. So let's go look at today's homework. We already looked at the mini exercises. They were very reasonable because they were just printouts. And if we look at the printout things again, you can easily tell that the goal of those printout exercises is to check if you understood the cycle routines. There's a do while here, and we're just checking if you understand what the do while is doing. In the second one, there's a do while with a break. So I'm just trying to make sure you understand what break is doing. So try to reason by hand when it's going to stop and what it's going to print. This one has a do while and a continue. So you notice I'm forcing you to think about the do while, I'm forcing you to think about the break, and I'm forcing you to think about the continue, sorry. So what are we doing as homework? Okay, so we are making a program that reads from standard input. So let's take notes here. Standard input, this means you're going to be using getchar. Please don't use scanf. We haven't seen it in the book yet. When you use things that we haven't actually seen yet, you are making your classmates more confused than they need to be. Please don't use things we haven't covered in class yet, because it's very confusing for people who are barely learning when you guys jump around to stuff we haven't seen before. Okay, then it says reproduces the content in standard output. For that, we can either use putchar or we could use the printf, because we have already seen printf in the book. Okay, so what does it do? It replaces all digits with a single X. So if I write any digits in standard input, in the output, the only thing we're going to see is a letter X. So not one X per every digit, but an X for any sequence of digits. So if I put like hola, and then some digits and a bye, I'm expecting to see an hola and an X and then a bye. Okay? And then there's an exception. except for when the number in question is enclosed in one or more sets of parentheses or quotes of any kind. So if I put hola, and then I put in parentheses the number, and then I put some other digits, and then I put a by, what am I going to be looking at? Hola is going to be there. The number in parentheses is also going to be there. The number that wasn't in the parentheses, that's going to be on X, and then there's going to be a by. Okay? So it can be regular parentheses, it could be brackets or curly braces, it could be single quotes, or it could be double quotes. You don't have to worry about any funky quotes additional to this because these are the ASCII ones. So if the number is inside any of those things, then it doesn't become an X. And it could be inside many things. I could have an hola, and then there could be a bracket, which has a parenthesis, which has a curly brace, which has a single quote, which has another bracket. And then I could have a double quote, and then I could have some numbers there. Let's make them less so it's easier to type. And then I could close carefully all of this stuff here. So if I put this in, it's going to come out right at it as it is because those numbers are inside all of that stuff. Okay? All punctuation is omitted. So if I have any points or commas or exclamations, those are also removed. So if I write something like that, the hola will survive, the parenthesis will survive, and the by will survive. But the punctuation, which is the question marks, the exclamations, and the comma, they will have to leave. Any other input is reproduced as is. The program exits upon encountering an EOF within the inputs. So you can use Control Ds, Control Zs, Control C, something to kill your program. It's pretty much like we've done before. So things we need to know from the reference card so we won't struggle with this. First of all, how to check if what we're looking at is a certain kind of thing. So we would want to know if it's a decimal digit. So like if it's a number between 0 and 9, we can use the is digit in the C-type H. So C-type H is going to be your friend. It's going to have the is digit. We also have another interesting routine we can use, which checks whether it's punctuation. Just remember to check for the parentheses first, because the parentheses are special. All other punctuation you are going to ignore. The parentheses need to be respected. So this is a relatively simple homework. As you can probably guess, we need a while or a do while to be able to do the get chars. I would probably use a do while with the get char inside the do while, or a while with the get char in the conditions. We are probably going to want to use some kind of break continue situations to, like when I see a digit, then I'm just going to skip to the next symbol, unless I have a flag that says that we're actually inside a parenthesis, in which case I do a different thing. And then when I do see a parenthesis close, the one that we had opened, then we need to do something else. If you want to make a perfect homework, you're going to worry about balancing the parentheses, like closing with the same kind. So you wouldn't take into account like opening a regular one and then closing with a bracket. But if you just want to point from the homework, forget all that. Just read all the parentheses, all the opening ones as if they were one same thing, and all the closing ones as if they were one same thing. So those are like the difficulty levels here. The whether or not try to balance the parentheses. So this is a pretty straightforward homework. This shouldn't be difficult. The mini questions are really extremely easy. And let's go check if we have done those mini questions yet, because that's what I really need everybody to be doing today. It's very sad when you guys don't do those. So let's go look at them again. 4 people are actually listening to me and have done some of those. So before you disconnect today, please answer at least one of the mini questions of chapter 3. Remember, if anything is confusing in chapter 3, it means you need to read again chapters 1 and 2, because everything they're talking about has been talked about previously in the book or is now being explained in detail. They don't jump over stuff. If there's a sentence or a paragraph or something in the book you don't understand, get a screenshot of the book, put it on the channel, and we can talk about it. If you want to talk about more advanced things in the book, we actually have a book club channel for this book where you can discuss future chapters as well. On this channel, we're going to try to discuss the chapters we have covered in class thus far so that people don't get horribly confused. Remember, the homework needs to be in your repository before class starts next week. Next week, we also need to look into the exam system. I could actually show it now because we have a little bit of time, but it's going to be more urgent to look at it the week after, because we're going to have a midterm exam on the 22nd. So we just have the next class, and then there's going to be a midterm. So how do we take the exam? We're going to use an online exam system. Let's go see if it's actually up and running. You guys can read the instructions here. Very important you read the instructions. We'll talk about them next week. There is an exam system. You will go in here, you will put your student number, you will put the same email, you will select that you're doing the media curso, and when we're practicing, you choose practicar. When it's actually the date of the exam, I'm going to give you an access key here, and you're going to select the second option. It's going to create you an examination. And what we have here are blanks to fill. So you need to fill the blanks. So you just write stuff here. I'm going to put some of them right. Other ones wrong. We'll look at this in detail next week. You could start practicing with it. To know what goes in every single one of these places, sometimes you need to read previous parts of the code. Like here, for example, there's supposed to be a mux in here, and you're going to know it if you actually read all of the code. You're not going to know it otherwise. Let's make some more mistakes. More mistakes. Then we'll grade, and apparently now I have a problem. Now what did I think I wrote something in the field that shouldn't be written in the field. Which field did I write it in? Let's look at it. When people write stuff that simply doesn't belong there, they can break the system, and I broke the system myself now. How did I break the system? I can't tell how I broke the system. Because there are some characters you're not ever supposed to write. I'm gonna have to check how I broke it, and I'll let you guys know when I fixed it. Maybe I'm missing an answer. Is there a box I didn't write anything? No, there aren't boxes where I didn't write anything either. I'm gonna have to check it. But basically, these things will grade you. It will give you your result. Let's try to make it a little better. Maybe if I write the correct stuff, it's not going to have a problem. Yeah, every time you practice, it's going to make you a new one. This is supposed to be a C. There, the blanks are going to be in different parts. The code's always going to be very similar. So this can't be a while, it has to be a do. That has to be a numerical value. This one's supposed to be a new line. Printf is supposed to end in a, okay, there it goes, that's right. What's the name of the array we have? It's called character CS is going to be, I'm taking the arg. So this, I'm substituting with that. Here I am printing the SI. That's a modulo. Here I'm printing a new line. And it still doesn't work. I've broken something in my system. I'm going to fix the system. But I'm going to stop the stream while I fix it, and I'll go on the voice channel. If you guys have any questions about chapters 1, 2, 3, homeworks 1, 2, 3, and I'll let you know as soon as I fix this. I think I have an off by 1 in the index somewhere, but I'm sure I can fix it within 15 minutes. So let me give you guys the link to the stream, and I'll debug this stuff here.